Okay, so it says which equation illustrates the associative property? The associative property, if you look at the word, if you're having a hard time remembering this one, associative, I think of the word associate. And although this might be a lame mnemonic, it helps me when you associate with somebody, right? Let's say you're over here, and right, we got this person over here, and then another person. Well, if you associate with somebody, you kind of hang out and talk to them, right? So maybe these two people are hanging out together, right? But this person's not associated with them yet because they're not yet in the parentheses. Let's say we're adding them up. Well, when you use the associative property, what you're saying is that these three people can be associated in different ways, and we still have the same outcome. In a sense, we still have the same party, so to speak, like if we're all hanging out together. So let me just copy this and show you what I mean. So the point is that it doesn't matter. Oops. Drag these people over here. Okay, well, it doesn't matter if these two people are hanging out first or these two people are hanging out first. In the end, let's say at this party, they all associate with each other, right? Or hang out together. In other words, you can have different groupings. Now with numbers, this just means that if you have, let's say, 1 plus 2 plus 3, well, it doesn't matter if I add 1 plus 2 first, or if I go back and say, oh, well, I wanted to add 3 plus 2 first, or 2 plus 3 first. Will I get the same thing? Well, if you do get the same thing, right, which we do, in the end, then the associative property is true for that operation. So for addition, if we're adding up everything, and multiplication, if we're multiplying everything, it doesn't matter how you group them. It doesn't matter how they hang out, so to speak. You'll still get the same result. So that's what we're looking for here, addition or multiplication, where the only real difference between the left and right sides of the equation is the way we grouped the numbers. And here I would go right for choice 4 because notice the order hasn't changed. It's x, y, and z in both cases. We're using all addition, but in the first one we grouped the x and the y, and the second one we grouped the y and the z first, and we're saying, well, they'll be equal in both cases, so that's the associative property. The third line here, x, y, and z, or z, y, x, is commutative, right? The commutative property moves things around. Choice 2, x times y plus z. This is distribution over addition, right? X times y plus x times z. And then here, x plus y plus z, if we don't change anything, we're not really using the associative properties, right? Anything x, y plus z, x plus y plus z is going to be equal to itself. That's true, right? That looks like a version of the identity property to me, although I'm not actually sure about that. I have to think about that one. All right, thanks.